go ahead and record this meeting since we have a couple people gone. All right, so for homework, you were to do lesson 13, which was playing with the with changing the period of a graph, right? How do we do with that homework? Do we have questions? Anybody have questions for me? No? Okay. Well, we are going to do some more variations on graphs. Let me get my camera set up, the document camera. Sorry, it's taking a minute. I think I didn't have it quite plugged in, so that would explain that. Okay, so we're looking at this time, what happens if you add or subtract something to x before you take the sine or cosine of it? So I have some examples here, and we can go to Desmos to see how the graph will change. Let me, oh, there, shared screen for 2 seconds. Now let's go back. And let's go to Desmos together. Okay. There's a lot of things on my screen I'm trying to get rid of. Sorry, guys. Okay. So, like the first one is we're just going to graph the sine of x minus pi. If you hit option P, that gives you pi divided by 6. And remember, okay, remember that you can go, can you guys all see my screen? I need you guys to say yes or no.
Yep. Yeah.
Okay. So you go to this little wrench thing and you can say, hey, let's step by, and maybe we want to do maybe every pi over, in this case, we're going to do pi over 6. So that we have radians in terms of pi on the x-axis. I mean, we have radians anyway, but that gives us in terms of pi. So if I click here, that looks like the start of the sine graph, right? And like it goes, remember, sine graph starts at 0, high point 0, low point 0. So it looks like it's starting at pi over 6 and ending at 13/6 pi, where if I just graph sine of x, it starts at 0 and ends at 2 pi, but this is starting at pi over 6 and ending at 13/6 pi. So what does it look like is happening there? Graham, what would you say is happening to the graph? Graham, can you hear me?
I couldn't hear you. Repeat.
So the blue is just the graph of sine x. The red is the graph of sine of x minus pi over 6. And I see that if I look at where it's starting, it looks like the cycle starts at pi over 6 and ends at 13.6 pi. So what happened to this graph, to the blue graph, to get the red graph? What is this minus pi over 6? What did it do to the graph?
It shifted it over to the right one.
One what? Like how much did it shift it over? Like it normally starts at 0, and now if we click on where the red curve hits the x-axis, that looks like it's the x-coordinate there is pi over 6.
8 by a 6, right?
Looks like it shifted it over pi over 6. Exactly. If I change this to pi over 4, okay, and again, I can click on these spots to see what those values are. Again, the blue is just sine. The red is the sine of pi over 4. So what does it look like? X minus pi over 4. How did that change the graph? Tessa?
It shifted it over to the right, like pi over 4.
To the right, pi over 4. Okay. If I do pi over 3, hey, what does that look like happened? Ian, does it move right pi over 3 again?
Yep.
Yep, that's what it looks like. What's going on? What if I change this this minus sign to a negative? Excuse me. What if I change this subtraction sign to an addition sign? What would be your guess as to what would happen? Will, do you have a guess if I change this to plus pi over 3 instead of minus?
I'm going to go ahead and say it would shift the other way.
All right, so again, normally sine starts here at 0. If I look here, negative pi over 3, and again, low point, high point, excuse me, 0, high, 0, low. There we go. From negative pi over 3 to 5/3 pi, so it's still, the cycle still is taking 2 pi. So has the period changed? Anna, does the period change?
No.
Period hasn't changed. It's just where it's starting. Instead of starting at 0, it's moved over pi over 3 to the left. All right. Here's kind of a cool thing. Maybe I'll just make this. Okay. Yeah, I forgot to show this the other day. There's something called sliders in Desmos. If you type just a letter, then automatically this pops up, add slider. And then if I click on that, it will add a slider. What that means is that K right now is at 1, but it's going to let K range between negative 10 and 10. And if I hit this little button, it lets it move. So K is changing values. It's going from negative 10 to 10, and we can see that the graph is moving as K changes. Isn't that pretty cool? You can stop it. So like the other day, yeah, we got to do this because this is way too cool. If I had done AX, add slider A, sure, let's add slider A. And I don't really want it to go from negative 10 to 10. I just want it to go, we'll go from 0 to 4, and then hit play. And we can see that that variable, the A, is affecting the period of the graph, which is what we saw last time. So that's pretty cool. And I don't know, we'll just call this J, just making up letters. If I put J, a constant, in front of the graph, what did that do to the graph again? What does that change? Maggie, do you remember having a number in front of the graph? What does that change?
oh, sorry, I didn't have my thing on. It changes like the height of it from on the y-axis, right?
Right. So that's called the amplitude, right?
Mhm.
So let's see what happens here. Look at that. That amplitude is changing. Pretty cool. You can even have two sliders going at once. So that gets pretty insane. All right, so I kind of love sliders. Yeah, we'll go ahead and get rid of those, but they're kind of fun to play with. So what we're seeing again is that if you have x plus or minus a value, like pi over, I'll just do k, add a slider. X plus or minus a value, it doesn't change the shape of the graph, it just moves it left or right. Okay, so it's what we call a horizontal shift or translation. Questions about that? Is that making sense? Yeah? Gotta let me know if it's not. All right, so let's go back to this. So we saw with the minus pi over 6, it moved right pi over 6. And the minus pi over 4, it moved right pi over 4. The minus pi over 3, it moved right pi over 3. And we didn't do pi over 2, but guess what? It's going to move right pi over 2. X minus pi, it'll move right pi. And then we said when it was plus, it moved left pi over 4, left pi over 3, left pi, left 2 pi. What do you think about the graph of sine of x plus 2 pi and the graph of sine of x? When you move left 2 pi, what's that going to look like? I'm going to go back to Desmos. All these things on my screen. Okay. Two pi. Well, I don't see two graphs. Why is that? I only see one graph, but I graph sine of x plus 2 pi and sine of x. Why would that be that I don't see two graphs? What do you think, Joe? Do you have a thought on why I don't see two graphs?
Not really.
Okay. So x plus 2 pi would move it 2 pi, right? To the left.
Yeah.
Huh. What about others? Why do you think I'm only seeing one graph?
Because it shifts the line by the same distance of the period.
So that was Will, right?
Yes.
Yeah. Like if you move left 2 pi, you're right at the beginning of a period. So if you start a period there, you can't tell that it's like different. So the fact that it is the period means that it's going to look exactly the same as it did. And if I did minus 2 pi instead of plus 2 pi, that's going to move it 2 pi to the right. So it's going to start here. Well, there's already a period starting there. So that's kind of cool. All right. Back we go. Okay. So, or what do we know? We know that if it's x minus a value, it moves h units to the right. And if it's x plus a value, it moves h units to the left. Now, here's one thing that's kind of, I think, helpful to maybe help us understand why it's moving. It sort of seems like it's moving the opposite of the way you might think. Like minus pi over 6, it seems like we should be subtracting pi over 6, so it should be going pi over 6 to the left. Well, we know that as the angle goes between 0 and 2 pi, that's one cycle. That's one period. A period starts at 0 and ends at 2 pi. That's like our basic cycle. Well, the expression for our angle isn't just x now. It's x minus pi over 6. So as x minus pi over 6 goes between 0 and 2 pi, I would get that basic cycle. If I solve this for x, even though this is minus pi over 6, but to solve, I have to add pi over 6, right? So I add pi over 6 and I get 2 pi plus pi over 6, which is going to be 12, that'd be 13/6 pi, which is what we saw. Okay, so it's because the x minus pi over 6 represents my angle. And when is that? X has to be pi over 6 for x minus pi over 6 to be 0, which is what I'm seeing here. That x has to be pi over 6 for x minus pi over 6 to be 0. So that's why it's moving right. This is also kind of just a cool technique to figure out where my cycle should start and end. Whatever my angle is, I put it between 0 and 2 pi, solve for x. My cycle should start at pi over 6 and end at 13/6 pi. And one more time. Go back to Desmos. So the x minus pi over 6 if I look at where it started at pi over 6 and added at 13/6 pi. We just added pi over 6 to 0 and pi over 6 to the 2 pi. So that is what I was getting there. All right. Okay, can I get a thumbs up or down if we understand this or not?
I'm a little bit confused considering I just missed like some of it, but
You missed some of it?
yeah.
Okay.
And see the first half of what you were doing.
What do you mean you missed the?
Like I just wasn't here for the first like 25 minutes of class, so I didn't see any of that.
Okay. So we're looking at when you add or subtract something from x, and we're seeing that when you subtract something from x, that moves it right that amount. When you add a certain amount to x, that's going to move it to the left by that amount.
And that's just like on the graph, right?
Mm-hmm.
Okay.
Okay. Okay. All right, let's go ahead and go to the next page and start doing some examples. Okay, we got a good half hour yet. So let's use what we've learned to graph. Let's use what we've learned to graph some functions. Now, this 2 in front of the sign, what do we know that's going to do to the graph? Tessa?
You would multiply it by 2.
So what does that change?
Oh. The period.
Hmm?
Would it change the period?
So this is after you find the sign, then you multiply by 2. So you're really multiplying what would have been the y value by 2. Does changing the y value change the period?
No, it changes amplitude.
Changes amplitude, right. So the amplitude is going to be 2. So that means the function is going to go between -2 and 2. So that's the domain is affected. The domain is easy, guys. It's always all reals. What about the period? Do you think the period is changing any? Am I multiplying x by anything? No. So the period's still going to be 2 pi, but I am subtracting something from x. So is it going to move left or going to move right? Graham, which way is it moving?
It's going to move to the right.
It's going to move to the right, pi over 2. So normally, right, normally the period is between 0 and 2 pi. And so I would divide that into 4 equal spaces, and then I would do my graph. I'm just shifting it over pi over 2 to the right. So instead of being between 0 and 2 pi, it'll be between pi over 2 and 2 pi over 2 more than 2 pi, which is 5/2 pi. So it's going to range between here. So sine, I know, starts at 0. It's a high point. I'm going to call that 2. Hits 0. It's a low point. I'm going to call this -2 down here. And then back at 0. So I'm not starting at 0. I'm just starting at pi over 2. So I can sketch in. Still want you to mark those 5 key points. So it shifted. We went right pi over 2. That's what we call the transformation. We went right pi over 2. All right. Let's try the next one. 3 cosine x plus pi over 2. Why don't you guys try this one? Give you guys a minute to see about graphing this one. Okay, do you need more time or do you think you have something? Okay, let's go ahead and talk about it then. This 3 is going to change the amplitude, the number you multiply sine or cosine by on the outside. So that means it'll range between -3 and 3. Domain's easy, it's always all reals. I'm not multiplying x by anything, so the period is still 2 pi. It's x plus pi over 2, so I'm moving to the left pi over 2. So negative pi over 2, I want to mark. If I haven't changed the period, I know I want to mark every pi over 2. Okay, so again, normally it'd be between 0 and 2 pi. It's moving over pi over 2 to the left. Cosine, I have to mark my 1, 2, -3 and -3. Cosine starts up high, hits 0, hits a low point, hits 0, hits a high point. Those are your 5 key points. Draw in a nice little curve, and you should have that. How'd we do with that, guys? Having trouble manage. Oh, I see. I think I just move it. There we go. Okay, screen's not doing what I want it to do. So I'm gonna do this. Okay, Jay's giving me a thumbs up. What about other people? Can I get a thumbs up or down on it? Okay, only looks like a couple of you. I don't know. Well, sometimes you do that thing, the thumbs up, and then it goes away. Guys, got to let me know if you got questions. Wait, got questions? Are we okay? All right, let's go back. Okay, let's do the next example. All right, 2 cosine x plus 3/2 pi. Okay, I'm gonna let you guys try that one too. Okay, let's see. Will, would you mind sharing with us what you had for period and amplitude? Can't hear you, Will. I think you're still muted.
Add 2 pi for the period, amplitude of 2, range of -2 to 2.
Okay. And
Domain
domain,
of all real.
never miss domain. It's always all reals on these. Every sine and cosine graph, it's all reals. All right, and then how does it move?
It started at 3/2 pi behind the what do you call it? And I guess origin, and started up high, standard cosine from behind that.
Okay. So it started at -3/2 pi. Is that what you mean?
Yes.
So again, normally it'd be between 0 and 2 pi, but I'm shifting it all over -3/2 pi. So it looks like it's going to be between -3/2 pi and pi over 2. It's cosine. We need to start at 2. So up here, hit 0, hit a low point, hit 0, hit a high point, sketch it in. There's our cosine graph. All right, questions? Okay, -4 sine x minus 2 pi. How's that x minus 2 pi going to affect the graph? Anna, what would you say?
Can you repeat the question, please?
How does the x minus 2 pi, how's that going to affect the graph?
I don't know.
Okay, is it moving it left or right?
Oh, it would move right.
Move right. By how much?
By 2 pi.
By 2 pi, okay. Is it gonna look any different when it moves right by 2 pi? What do you think, Maggie?
No.
Because,
I mean, you're usually just doing 2 pi as the, so I don't know who would change, especially since there's like, I don't know.
yeah. I mean, normally it goes between 0 and 2 pi, and then at 2 pi, it starts a new cycle. We'd be starting a cycle at 2 pi. So you could just graph the normal one, to be honest. This will just be the same graph as -4 sine x. So period of 2 pi, amplitude of 4, domain all real, range between -4 and 4. So even though it moves, it's gonna look the same. And knowing that, you could choose to just show this. What am I doing? I missed it. Okay. 0, high point, 0, low point, 0. So it's just going to look like -4 sine x. Oh, I forgot all about the negative. What's that negative do to the graph? Who remembers? Joe, what's that negative do to the graph?
Makes it goes downward first instead of going upward first.
Right. So here, pay attention to the purple graph. This is it. Pi equals -4 sine x. Yeah. So it's a reflection over the x-axis. Okay. So now we got some problems where we're going to write the equation of the graph. So look here, this says -pi/5, this says 4/5 pi, this says 9/5 pi. I'm writing the graph of sine. It looks like, well, there's a couple different ways that you can look at this. This is 4/5 pi. I know it's kind of small print. That's 9/5 pi. And this is -pi/5. So one cycle would be like this much, except what's different about this? Normally, sine goes up and then comes down. So what do I think is going to be going on in the equation? What would you say? Ian, what's going to go on in the equation, do you think?
It's gonna be like a negative sign or
What about the amplitude? The amplitude is?
-1 or 1, sorry.
That's a 2. It's going from 2 to -2.
Oh, 2, yeah.
Okay, -2 sine. Now what's the, is the period still 2 pi? Has that changed? What do we think? Kelsey, what's the period of this graph?
Isn't it still 2 pi?
And how do we know that? It is. Can you just talk to me about how you know that?
Because it's like in between, like the -pi/5 and 9/5 pi is just 2 pi, right?
Right. So from 9/5 to -1/5, that's a distance of 10/5, which is 2. So the period is still 2 pi, so that's not going to change anything, but it has moved. And so it looks like it's starting at negative pi over 5, so this should be x. Is it going to be plus or minus? Graham, is it going to be plus or minus?
Plus.
Plus. Pi over 5. Okay. So the period we said was 2 pi, the amplitude is 2, domain is all real, the range was -2 to 2. Transformations to x, we were changing the x court value, so it moved pi over 5 left. So that'd be what transformations that affected things along the x-axis. To y is instead of going up, it went down. So that would be a reflection over the x-axis. That negative caused that reflection. Okay, questions on that? Okay, write 2 equations, 1 sine and 1 cosine for the graph shown below or on page 4. All right, so page 4, got this graph here. I can look at it as either a sine graph or a cosine graph, and I'm wanting you to write an equation for both. One where I think of it as sine, and one where I think of it as cosine. So you want to think about sine, starts on the x-axis and goes up and comes down. Goes high point, 0, low point. So it looks like you want to think about it as starting at negative pi over 3 and ending at 5/3 pi if you want to do a sine graph. Okay. How do I finish that? What number do I need in front of the sine, if anything? What do you think, Maggie?
What'd you say? Sorry.
So do I need a number in front of the sine? Do I need to be multiplying the sine by something?
Is it pi over 3? I don't. Where would that be in the parentheses?
That would be in the parentheses because it's moving pi over 3 to the left, right? So am I going to do minus pi over 3 or plus pi over 3?
Plus.
Right. Okay. What's the amplitude, though, of this graph?
2
It's 2. So where does the 2 go?
in front of sine.
In front of the sine, exactly. Is the period still 2 pi? From negative pi over 3 to 5/3 pi? Is that 2 pi?
Yeah.
Yeah? Okay. People okay with that? Yeah. So transformations to x, what happened here was that we moved pi over 3 to the left. So y, we stretched it out, right? It's a vertical stretch by 2. That's what changing the amplitude does. It stretches it by a factor of your amplitude. All right, cosine, we know starts at the high point and then ends here. So I've shown you these values, the values at the 2 high points. So I want to look at that as a period. So I'm going to give you guys a minute to write an equation with cosine for this graph. Let's see, Anna, do you have an equation?
No.
Have you started on it? Have you gotten anything?
No, I'm still trying to figure it out.
Okay. Can you tell me what is the amplitude going to be different if I think about it as cosine? Or is it still 2?
Still 2.
Okay, so I'm going to have y equals 2 cosine. Period's still 2 pi, that's not changing. What about the shift? Cosine, I need to think about it as starting here, ending there. How do I do the shift? Is it going to be x plus or x minus something?
X plus.
Okay, so it seems like it'd be x plus because I'm moving to the right. But if we go back to this first page, when I had x pluses, it moved to the left. When I had x minuses, it moved to the right. So it's going to be an x minus, and I'm starting at pi over 6 instead of at 0, so it's x minus pi over 6. Okay. So transformations to x, we moved pi over 6 right, and we still had a vertical stretch by 2. Okay. Questions, folks? Okay. So we haven't combined, what if there's a change in period and a shift? Okay. And so that's what we're going to look at with this next thing. I've got 2 equations here. Notice this one I have 2 times, and then in parentheses, x minus 2. And here I have 2x minus pi over 2. So it's not 2 times the quantity, it's just 2x minus pi over 2. Well, what do you think the period of this graph is going to be? With a 2 there, what do you think the period's going to be? Ian, do you have a prediction? Can't hear you, Ian.
2.
The period's going to be 2?
For the first one or the second function?
Either one. How do we, if I just have y equals cosine of 2x, how do I find the period of this, folks?
It's just 1, right?
1 what?
1 pi, or just pi.
Okay, because the period, we would divide the period by the 2 and be pi. Well, that seems like a fairly reasonable prediction, is that it's going to be pi again. But do I think these graphs are going to be the same? I see this minus pi over 2, so I'm thinking shift right pi over 2. I see it here, shift right pi over 2. Are these the same graph though? Are they both going to have a period of pi and be shifted right pi over 2? What do you think? Or are we a little confused? Joe?
I'm confused on what the difference is going to be.
Okay. That's why we're taking time to look at it. So let's go back to Desmos. All right, so cosine of 2 times the quantity x minus pi divided by 2. And this we're going to make the cosine of 2x minus pi over 2. Okay, so cosine, remember, starts up here. So the red, which is the 2x minus pi over 2, the cosine starting, it looks like at pi over 4, that's a high point, and ending at 5/4 pi. Is the difference between pi over 4 and 5/4 pi, is that pi? Does it look like the period is pi? Kelsey, did we get the period right?
Yes.
Yeah. And it looks like this has the same period as well, the blue. Okay, but instead of starting at pi over 4, it's starting at pi over 2. So this equation, right, at 2x minus pi over 2, this didn't actually tell me the shift. Here, when I had the x minus pi over 2 in parentheses, that did tell me the shift. I actually am starting the cycle at pi over 2 and doing a period of pi. So I kind of like the second one better than the first one. Okay. So when it's written like this, when you have a number times a quantity, x plus or minus something, this tells me the shift. If it's multiplied out, this does not tell me the shift. So let's go back to, all right, so here, this was the shift, right, pi over 2. Here it wasn't. But if it was factored, what would this have to be so that 2 times this number is pi over 2? If I tried to factor a 2 out because I'm like, oh, I like this better where it's factored out. So I need to factor this out. What number would go here? Ian? 2 times what is pi over 2? Anybody? 2 times.
One.
What was the shift in that problem? Remember?
2.
Go ahead.
Isn't it pi over 4?
It was pi over 4. What's 2 times pi over 4, folks? All right?
Pi over 2.
Pi over 2. So if I factor this out, these are equivalent statements because this gives me 2x minus pi over 2. And yeah, the shift was pi over 4. So if it's not in a factored form, if I can put it in a factored form, then this tells me the shift. Okay? All right. So let's look at this. Predict the period and horizontal shift of each of the following functions. 3 times the quantity x plus pi over 4. What is this 3 going to do? How's it going to affect the period? What's the period going to be? Anna, can you tell me the period? There's a 3 here.
Isn't the period gonna be 3?
Nope.
Wait, no.
Remember we said when this number is bigger than 1, the period gets smaller. The period is normally 2 pi. To make it smaller, I divide by that value. So I take 2 pi divided by 3. So the period is 2/3 pi. Sorry, go ahead.
Nothing.
All right. Is it in factored form? So therefore, I can just look at it to see the shift. Is it going left or is it going right? Tessa, which way is it going?
It would go left.
So it's going left, pi over 4. All right, 5x minus pi over 4. Is it in factored form? Kelsey?
No.
Okay, what's the period going to be?
2/5.
Yeah, you take your 2 pi and divide it by 5. We know it gets smaller. All right, so I got to put it in factored form so that I can see what the shift is going to be. Okay, so this is a little weird. I know it looks a little funny. What does it need to be so that when I multiply 3 by 5, I get pi over 4? Five times what equals, basically 1/4. I'll throw the pi in later. 5 times what equals 1/4? It's a fraction. What fraction? 1 over what? Ian,
Yeah,
what is it? 5 times what?
20.
1/20.
20.
Yeah, exactly. So 1/20th pi. 5/20ths is 1/4. So it's a horizontal shift of 1/20th pi. All right, y equals sine of 1/3 x plus pi over 6. What's the period going to be? Graham, what's the period? That 1/3 x, what's that do to it? Is the period going to get smaller or bigger? I mean, those are the same. Yeah,
It's gonna get,
what?
no, it's gonna get smaller. No, it's gonna get bigger. Sorry.
Okay, so what's the period going to be?
Is it gonna be 3x? 3 pi, sorry.
Well, what is it normally?
2 pi.
2 pi is getting bigger by a factor of 3. So 3 times 2 pi. So 6 pi. Whatever this is, you're multiplying your period by that. All right. And again, this is not in factored form, so I need to get it in factored form. So I need to think about it as sine of 1/3 x plus what equals pi over 6. Well, I need a, if I had a 3 here, when I multiplied, the 1/3 times 3 would cancel, and I would just have pi over 6. So 3/6 pi, which is pi over 2. So it's going to be a shift left of pi over 2. This is a shift right. Forgot to say that. Okay. And one more. What's the period going to be here? Will, what's the period going to be? Sorry, Will. Did you say something? What's the period going to be, Will? Will.
Yeah, I'm here. I'm trying to figure that out. So if it's outside of parentheses, do we? I'm not sure.
Well, it really doesn't matter if it's 1/4 outside. So 1/4 affects the period.
I'm sorry, I didn't get any of that.
In terms of the period, it doesn't matter if it's 1/4 is inside or outside the parentheses. It's being multiplied by x. That's all that matters.
Okay, so it'd be what? 4 pi? Is that what we're multiplying? There's no being multiplied by 2 pi. So it's
Period. 2 pi. You're going to get bigger or smaller?
going to get smaller. So it'd be what?
When
Half
this
pi?
it gets bigger. It's like everything is the opposite of what you think it was. When you have a negative, it moves right. When you have a positive, it moves left. And this is less than 1.
Oh yeah. Okay.
So it's normally 2 pi, but you multiply
So
by
it would be a pi over 2.
no.
No.
Normally 2 pi.
I thought it was divided by.
No. If it was cosine of 4x, and it'd be pi over 2. since it's 1/4, it's bigger than it's 8 pi.
Okay.
All right. Is it in fact normal?
I'm sorry. I'm getting a static noise. I can't quite
No, we can't hear anything you're saying.
Really?
make out what you're saying. Now it's
And
frozen.
class ended like 5 minutes ago. No, it just sounds like static.
Yeah.
All right. Okay, we'll hit this again on Thursday, guys. All right, and I don't know what's going on, why we're not getting great audio, but we will work on it on Thursday. No homework, okay? See you.
Thank you.
Thanks.
Thank you.
Thank you.
Kathleen?
Yeah.
Was the homework due today? Like, were we supposed to finish the lesson 13 and the homework, or just do the homework for like the...
Do the homework for lesson 13. Did I not assign that last time?
I was confused on what was due because like I thought you said do half of it because we didn't like we like left one page of the trick, like the 13.
Really?
I was confused.
Well, great. I probably screwed that up. Okay, because what had we not done in the notes?
I don't have like the last page, like the full last page done.
Okay. Okay. All right.
Good.
Thank you for letting me know. I'll take care of. We'll fix that on Thursday. Okay.
Okay.
Thanks.
All
Tara.
right.
How you doing?
I'm just really tired. I like just woke up
Really? Are you
for this class.
summer mode and staying up late and all that?
Yes, like 100%.
Yeah, people seem kind of dead today, but all right.
Okay. Have a
Thank
good day.
you. Bye.